right, and with that, hello everyone. Welcome to the, I think it's the 6th meeting of the semester. How's everyone doing?
Great.
All right. Not a pretty day, but it's all right. Yeah, I got a couple things to present. You want to talk about ISR today, right? All right, I'll let you do that in a couple minutes. First thing, just your weekly weather challenge update. Keely, you still got a couple days left. Don't forget to get forecasting by 7 if you haven't done that. He's kicking all of our butts. I'm not gonna lie. We're not doing very well. We can look at results here for today.
You can at least change it to hypotheticals at least 56.
Yeah, you think?
At least 56.
Well, regardless, current as of right now, no one is over consensus. But that's okay. It's a hard city, and everyone's first city gets dropped anyway. Anthony's right in there. So is Richard and Devin. Yeah.
Can we look at Roll
I mean, if you would like to see that, where was your name?
204865.
204-865. So yeah, you're not doing terribly. Yeah, I mean, you know, the city sucks. We're gonna get a new one. We actually can register, or we actually can vote for the new city currently. As Anthony has detailed in the Discord, the process is a little different now than it has been in the past. You need to put in your forecast information here, but you just vote on a region, and then they pick a city within that region. It's probably a good idea to pick Central Plains for this time because of all that stuff that's forecasted to go on next week. So yeah, I would definitely recommend voting for Central Plains. But yeah, hope you guys are all enjoying Weather Challenge. It should get easier from here. Killing is just a nightmare. But yeah, do you want to talk about anything at all? You want to do that?
Forecasting operations here. I think they've got them on Purple Post now, but let me double check. Because for a while, they kind of went through a transition where they got kicked off Purple Post because they didn't do anything. But I don't know. Nope, I don't even think they're on here anymore. So weird. So ISMA, it really is more emergency management side of things. But they do outreach events like they have an event coming up on October 20th, emergency management day on campus in front of Cantor Hall. Not quite sure what they're going to have. They're going to have different simulations, events going on over there. But they do make trips to the State Emergency Operations Center in Springfield, which is the major event that goes on, whether it's storm-related or earthquakes or terrorists or anything like that. That center gets activated. That's where everything goes on, from the governor to everyone's there. It's a big document in emergency management type of things. They also do, like I said, at Discord. They went and helped recovery in Washington, Illinois. One of those things. And they also been asked to sandbag along the Mississippi River during the flood of 19. We couldn't do it because of climate change. But that's something they do. They make trips everywhere. They go to conferences. You really get thrown into the emergency management side of things, which if you're, no matter where you're going to go, chances are you're going to deal with emergency management of some sort. Unless you're in a private machine, you probably wouldn't, but you still would have to deal with the emergency management process of prevention, mitigation, recovery, those types of things. And so it's just a good club to also be in. Because then you make contacts. As far as the emergency managers go, we emergency managers, if you want to work with weather centers, if you make good contact with them, you can put them on your resume, and all the weather centers offices know the emergency managers. That's who they literally talk to every day. And so, we can ask about it. What's good for you? So that's, another thing you can do with them. But yeah, it's just getting ready to get on our feet. I told them to create a Discord. We'll see if they do. I think they will, but yeah, so that's really, all I've got to say about them. Right now, I'm kind of just literally starting fresh. And we'll see where it takes us. If you're interested, let me know. I'll send you the links. I'll post links. Discord, and yeah, so that's really all I got to say. Any questions about ISR?
I will say just emergency management in general is something to try and get into, whether or not it's something you minor in or just a couple classes, or even if you just interact with their club at all. It is a good idea. Are they interested in coming to any Spirit Weather Club meetings? They don't have to, obviously.
I haven't talked to them about it. They're still on Zoom right now.
I see.
So I'm not sure what their status is as far as making offices. I think they're trying to, but they're kind of a little bit more cautious about it.
That's all right.
Yeah, so once we get to that point, I will definitely bring that up where we should have some.
That's good. And of course, we are zooming the meeting as well. But yeah, there was a couple things that I wanted to do this semester related to emergency management in particular. I do know Chad Sperry, I work at the GIS Center, and so he's been heavily involved in the EOC down at Tanner Hall. And so I was hoping that we could get a group of students in there just to kind of see what goes on there. That's still on the table, so I just talk to them about it. But yeah, I would definitely recommend doing ISO at the very least, get some information for Anthony in case you have time to go ahead and do that. We usually meet at Wednesdays.
This year it's Wednesdays. It's been Thursdays in the past. It's kind of right now. It's not formal. It's kind of more sporadic. It's like the meeting things going. Yeah, no one's talking about things.
Yeah, maybe we can convince them to meet on Wednesdays. So coming to Severe Weather Club and an ISO meeting would be convenient. But yeah, that's ISMA. I think that's all I wanted to talk about before my presentation. Does anyone have any other questions or concerns? All right, I'm gonna go ahead and pull this up then. Place for all this Zoom stuff. Let's see, that'll probably work. Yeah, okay. Go away. Go away, thank you, okay. All right, so the presentation that I'm going to be doing today is called Hurricanes, Wind Speed, and the Dangers of Pop Science. For those of you who don't know, pop science basically just refers to any form of media that is about science that is geared toward a general audience. I'm going to show you a video that was recently released by a fairly popular pop science YouTube channel. You've actually probably heard of them and seen them before. They're called Hidden Earth. It was about hurricanes. I do think that this video is generally good. However, there are a couple points that I wanted to bring up about it. So we're going to watch that first. Do you have a question?
I'm pretty sure I literally watched this video you're about to bring up like 5 hours ago.
Right. So yeah. So the first thing I'm going to do is I'm going to show you this video, and we're gonna So I'll let you guys watch that and form your opinions before I actually get into my take on this video. What was that? Pop science just refers to any media about science that is geared toward a general audience. Yeah. So I'm going to mute that.
Hi, this is Julian from Minute Earth. You've likely heard hurricanes referred to as category 1, 2, 3, 4, or 5. The higher a hurricane's peak wind speeds, the higher the category, and supposedly the higher the hurricane's threat. The idea being to easily convey the danger of an incoming hurricane to the public. Except, it doesn't work. In 2015, Hurricane Patricia approached Mexico with the highest hurricane wind speeds ever recorded at 345 kilometers per hour. A category 5 by a lot, and based on the wind category scale, should have made it the most destructive hurricane ever. But thankfully, it caused relatively minor damage and only a few people died. On the other hand, Hurricane Stan, which hit Central America and Mexico in 2005, was a mere Category 1 hurricane on the wind speed-based scale, supposedly the lowest threat level, yet it caused nearly 10 times more damage and killed over 100 times more people. Confusing, right? The problem is that the category scale is based solely on wind speed, but there are two other factors that are far more critical than wind in determining a hurricane's true threat. The most obvious factor is where the hurricane is likely to hit. Hurricane Patricia happened to hit a rural, sparsely populated area with mountainous terrain that quickly weakened the storm. Hurricane Stan tore through the populated Yucatan Peninsula and got stronger in the Gulf of Mexico before slamming into heavily populated central Mexico. And once a hurricane does hit, water is a much greater threat than wind. Ahead of landfall, a hurricane can push water in front of it, piling it up into a bulge called a storm surge that raises sea levels around the coast and produces massive flooding. Storm surges are by far a hurricane's most catastrophic product, followed by rainfall, which can also cause dangerous flooding. So, to accurately predict a hurricane's threat, we first need to predict the threat of storm surge and rainfall, which wind speed alone can't do. You also need to add a bunch of other things to the threat prediction model, including the hurricane's size, how quickly it's moving forward, a coastline's terrain, and average sea level. A larger storm slowly moving toward a flat, shallow coast, like Hurricane Stan, will cause the fiercest storm surge and most intense rainfall. Hurricane Patricia developed so quickly and close to the shore that it didn't have time to build up a storm surge at all, but the damage it did cause was due to flooding from rain. So if a hurricane's potential route, storm surge, and rainfall, and by extension everything that factors into predicting a storm surge and rainfall, are better predictors of a hurricane's threat than just wind speed, why don't we use all of that data to create a new category scale? In a perfect world, we would, except we haven't figured out how to reliably measure all of these things in real time. But that doesn't mean we're stuck with the unreliable wind speed scale, because there is a single measurement that beats wind speed alone at predicting destruction: air pressure at the center of a storm. Low air pressure in a hurricane pulls in higher pressure air, making the hurricane larger, creating stronger winds, and making it likelier to produce a large storm surge and lots of rainfall. We already measure air pressure in storms in real time, and it's easier to measure than wind speed. So if we replaced wind speed with air pressure to assign categories to hurricanes, we'd be able to give people a much more reliable sense of the threat. Ideally, we'd be able to use all the factors that best predict a hurricane's destructiveness to determine its category. But until then, one thing's for certain. With the current scale, we're simply throwing caution to the wind, and storm surge, and rain.
Alrighty, so after watching that video, you guys probably can guess at least a couple of things that I'm going to bring up about this video. But the first thing that I do want to say is that in general, I do think that this is a good video, or at the very least that the premise is good. So I do want to talk about a couple of things that I think the video did well before I get into some of the problems I have with it. Ooh, I hope that doesn't speak too much. Thanks, thank you. All right. So one of the first things that I really wanted to talk about is that it matters a lot how we disseminate weather information to the public, which is one of the main themes of this video. The reason for that is very simple. The weather is honestly too complicated for the average person to intuitively understand. That's not supposed to insult the average person at all. I mean, the atmosphere really is just such a complex system that understanding it is extremely difficult for people who aren't trained in it like we are. Therefore, it matters a lot how we communicate information about it. There are some examples that you guys can probably think of when it comes to how we talk about weather information. For example, watches and warnings. A lot of the time, people get confused when watches and warnings are given out. There have actually been studies that show that calling what we call watches and warnings, those terms, is confusing for the general public, because those words themselves don't convey what they're trying to say. When we say that there is a tornado warning, the word warning doesn't actually convey that there is a tornado on the ground and you get shelter unless you know that before. Of course, there are, information campaigns out there to make sure that the general public does understand that, but there is a push to try and change the terms that we use to describe those things because they can be so confusing to people. Another example is the creation of the winter storm outlook. If you guys don't know, basically the Weather Prediction Center created this new product. It's akin to the severe weather outlook that they also produce, which is basically just supposed to standardize how we diagnose and forecast for winter storms. The problem is a lot of local weather service offices, they have said that they don't like the product because it doesn't take into consideration any local wisdom that would be able to guide, how they basically diagnose how bad a winter storm will be. And so they don't like the product for that reason, because it could cause misinformation within the public. And so this is one of the central themes that I think this video does get right, because improper communication may lead to dangerous situations for the general public. This is why, they were talking about this in the first place. The other thing that I really wanted to highlight is that this video's main idea, which is that wind speed is a poor singular measure of hurricane severity, is an objectively true statement. The reason for that is very simple. The Saffir-Simpson scale, which is how we currently measure hurricane severity, depends only on wind speed. You can see the categories there on the right. But of course, there are many more factors that actually determine the severity of a hurricane. And the video, of course, talks about a lot of those. Rain and storm surge are the two most important ones. Those are what cause the most damage and the most deaths. And so that's an important thing to keep in mind. Additionally, though, a lot of things that aren't considered at all with wind speed is local topography, and impacted location relative to the storm, how developed the impacted region is. All of these things are going to impact how severe the storm is. And of course, using wind speed as a singular measure for that isn't going to factor any of that in. Now, with that being said, there are a few key points in this video that I don't necessarily agree with that they make, and so now I'm going to get into talking about a couple of those. The first one that I really am not a fan of is that this video seems to really downplay how impactful wind really is. Like you can see this graphic that they made on the right there, where they have these things feeding into the severity model. One of them is location of the storm, the other is storm surge, and those are really important factors. But look at what they have as wind there. Look at how tiny it is. It really feels like it's kind of misrepresenting how important wind can be. There's a big difference between Cat 1 and Cat 5 winds. Category 1 hurricane, which is baseline of 73 miles an hour, will cause minimal damage to well-built structures. You might lose like a few shingles on your house roof, but the house itself will be fine. Cat 5s, on the other hand, will absolutely level an entire neighborhood if it could. And so in this regard, you could say that the Saffir-Simpson scale is a very effective indicator for hurricane strength, specifically within the context of wind speeds. From the Dr. Finch quote, yeah. So Dr. Finch has said at least a couple of times that a Cat 1 is a glorified thunderstorm. And she's right. She used to live in Florida, and Cat 1 hurricanes just generally aren't that impactful, at least in that area of the world. Of course, you know, lesser developed regions will be impacted more by Cat 1s, but that's true of any storm. The less developed the area is, the more impactful it will be. I have an example of Cat 1 versus Cat 5 damage. On the left is a Cat 1 storm. As you can see, the damage is not nothing, obviously. There's that tree that got snapped in half. You know, these storms are still devastating no matter what the severity, but look at these houses. Obviously, there is some damage. I imagine this is probably caused by a tree falling on it, but the structures themselves are fine. I'm sure there's probably missing shingles and there's probably blown out windows, but the structures themselves are basically fine. On the right, however, just out of the way, whatever, it's fine. On the right, however, you can see Category 5 damage. This was actually taken from Hurricane Dorian. And as you can see, I mean, the damage is, it's just devastating. You can barely even tell that the debris here came from houses. And so again, in this regard, wind speed matters a lot. And I do think that the video really misrepresents how important it can be. Secondly, can I please get this toolbar out of the way? I just want it to collapse. I'm not sure. All right, well, the second thing that I wanted to talk about is the video's main assertion, which is that air pressure is a single measurement that beats wind speed alone at predicting destruction. When I first heard that, I said, whoa, what? Really? Okay. So I looked at the description. They actually do cite their source. It led to this article posted on weather.com, and then that led me to this academic article published in the Bulletin of the AMS, which is titled Surface Pressure, a more skillful indicator, or predictor rather, of normalized hurricane damage than maximum sustained wind speed. So I was reading through this article, and it turns out that this assertion does have a basis. They state in this paper that we recommend that more emphasis be placed on mean sea level pressure when assessing the potential risks from future landfalling hurricanes. The reason that mean sea level pressure might be a better indicator than wind speed alone is because low pressure strength correlates at least a little bit with hurricane size, as well as potential for rainfall, both of which impact storm surge, as well as just the total water that can be introduced by the storm. And so therefore it could be considered a better predictor in that regard. However, what I really don't like about this video is that it kind of implies that this is like a slam dunk, like low pressure is so much better than wind speed. Here's the thing though, if you also read this paper, they say mean sea level pressure explains about 60% of the variance in normalized damage. If you've ever taken a stats course, you would know that having an R² value of 60 isn't like great. Like obviously there is a trend there that does indicate some trend, but having 40% of your variance not explained by your model is very impactful. That's a lot of variance. And so for that reason, I just don't believe the assertion that it's so much better than wind speed. It is better, just not profoundly better. For one thing, wind speed correlates directly with mean sea level pressure anyway, so the measurements aren't even really that dissimilar to begin with. They are dissimilar enough that mean sea level pressure is better, but again, not that much. And additionally, what about all these other factors that determine severity? Rain and storm surge are the two biggest ones. And while sea level pressure does roughly correlate with those two things, it's a very loose correlation. It doesn't explicitly model that. It's just a single measurement. And so the added accuracy by that measure isn't going to be that impactful. Additionally, mean sea level pressure doesn't take into consideration other things, such as storm velocity. This is what made Hurricane Harvey so bad, was when it made landfall, it just kind of sat over the Houston-Galveston area for days and just dumped inches of water per day. And so that's what made that so bad. The mean sea level pressure doesn't do anything to predict that. Additionally, it doesn't take into consideration anything spatial, such as local topography, the location of the impacted region relative to the storm, how it weakens after landfall, how developed the impacted region is. That measurement doesn't consider any of that at all. And so again, the assertion that it's better isn't exactly true. Additionally, I do want to point out something funny that I discovered. I'm going to move this up here for you guys so you can see. On the left here, we have Hurricane Patricia, and on the right, we have Hurricane Stan. These are the two hurricanes that they use to demonstrate why wind speed is not an adequate measure of hurricane severity. On the left, Hurricane Patricia, which we know caused pretty minimal damage to Western Mexico, had a minimum pressure of 872 millibars, the second lowest ever recorded. Meanwhile, on the right, Hurricane Stan had a minimum pressure of 977 millibars, way, way less strong than Hurricane Patricia, and yet it caused, untold damage in the Yucatan Peninsula in central Mexico. And so I just think it's funny how the same examples that they use to demonstrate how wind speed isn't exactly an effective measure can also be used to demonstrate that sea level pressure isn't exactly an effective measure of severity either. Additionally, I want you guys to consider something, which is which measure do you think is better at communicating hurricane severity than the other? This is really conjecture on my part. I did try to find some research on this, and there just really isn't any. But I want you guys to consider, if you were to describe a hurricane scale to the average person, one being wind speed based and the other being sea level pressure based, which do you think they would understand more? If you were to explain the difference between a Cat 1 and a Cat 5 using wind speed, you could tell the person, oh, well, there's a difference between 73 mile per hour winds versus 155 mile per hour winds. And that person would probably be like, whoa, that's really fast winds. But if you told them, Cat 1 is 976 millibars versus 920 millibars, they'd probably be like, okay. The problem is that I don't think people would really be able to intuit what a really low pressure really means. People experience wind speed on a daily basis. They know that, higher winds are going to buffet me more. So really high winds might destroy my house. But they may not understand, like we understand, for example, that 907 millibars at the center of a hurricane is insane. But the average person probably won't. And so in this regard, one could argue that wind speed is the more effective measure here. Again, there's no studies on this, and I really hope there could be in the future, because I would want to know. And these 2 points do kind of feed into my third and final talking point that I do want to address. This is probably the biggest problem that I have with this video, and it's the following implication. The video seems to heavily imply that wind speed is used as the end-all be-all for measuring hurricane severity. And the fact of the matter is that just simply is not true at all. I mean, think about it. When was the last time you've ever seen a credible, reliable resource that uses exactly only Saffir-Simpson category to measure how impactful a hurricane would be? The answer is you don't. There aren't any that exist. The National Weather Service, the Hurricane Center, and local emergency management agencies, they aren't idiots. They know that wind speed isn't the only thing that affects hurricane severity. They know that storm surge is important. We have storm surge models now. They know that the location of the storm is going to be super impactful. They know that, in fact, local agencies, they're going to know better than any model could how developed their region is and how susceptible it could be to hurricane severity. At the end of the day, no authority actually treats the Saffir-Simpson category as the only measure of hurricane severity. That assertion is, at least in my opinion, bogus. Now, of course, there's a caveat to this. Some general media outlets might do this. It's easy to imagine a headline by some shaky news website that says, despite NH2 warnings, hurricane whatever only progressed or projected to be Cat 2. You could imagine a headline that exists like that, and if that were to exist, that would straight up be misleading and probably misinformation. But the thing is that we weather professionals, we don't control the media. That wouldn't be something that we put out, obviously. And so the concern with the public is that they shouldn't be looking toward general media outlets in the first place to gauge how they should react to a hurricane anyway. They should be going to their National Weather Service office or their local emergency management agencies, seeking guidance from there. And so at the end of the day, enough information exists out there for the public to make informed decisions. Of course, whether they can or do is beyond the scope of this presentation. There's a lot to be said about that as well. But yeah, so again, the assertion that wind speed is like the end all be all of measuring hurricane severity, it just isn't true. And I think this video does try to portray that, at least in some regard. All right, so you guys might be wondering, okay, at the end of the day, does this really matter? And I would argue probably not. One of the things to keep in mind is that Dr. Finch made a comment, I'll read that later. One of the things to keep in mind is that pop science is, of course, supposed to be simplified. These simplifications are required in order to reach their audience. If there weren't simplifications, they couldn't understand it. That's why people don't read scientific articles for light reading. However, the problem is that simplifications can lead to inaccuracies, which could lead to false ideas. It's not difficult to imagine a scenario where a group of people, well-intentioned people, but perhaps misinformed, watch this video and develop the idea that, oh, well, our emergency management officials, they don't understand how we need to use Saffir-Simpson scale. We need to use other things. And so they would write to their local weather service offices and their emergency management agencies and say, hey, you guys aren't doing it right, we need to change. And so at best, this would cause these agencies to have to commit time to saying that, no, we do use it properly. We factor in these other things. We just use wind speed because it's a standard and it's easily recognizable. And at worst, it could lead to mistrust of these agencies if people don't think that they're doing it properly. Now, does this actually happen? Probably not, but hundreds of thousands of people have watched that video. It's not difficult to imagine that at least a couple people will take the wrong message from this because of the simplifications that this video made. And while it is true that there is a space to evaluate how we assess hurricane risks and how we communicate that to the public, I'm not sure that a pop science video is the best place to do that. That's just my opinion though. So in conclusion, I just want to kind of give some objective truths here. Is wind speed a good singular indicator of hurricane severity? No, it isn't, for the reasons that we've discussed and the video discusses as well. It doesn't consider a number of factors that are very important to hurricane severity. Should there be more of an emphasis on mean sea level pressure as an indicator of hurricane severity? Yes, with an asterisk, which is that most of the people who actually make impactful decisions regarding hurricane severity and response, they already do. They already do factor in all these things. They use models that predict storm surge and rainfall, that kind of thing. And third is the assertion that mean sea level pressure is an objectively better single indicator of hurricane severity true. Technically, but they're both not very good. And there's a simple reason for that. It's not possible to fully capture the severity of a hurricane with a single measure. Even if mean sea level pressure could capture more aspects of a hurricane than wind speed could, it doesn't change the fact that it's just a single measure. It doesn't take into consideration anything related to space, or it can't model storm surge directly. We've been talking about Hurricane Sam the past couple of weeks. It reached high Cat 4 levels, but we're not saying it's a super severe storm because it didn't impact anything. It might have just diverted a couple of naval routes for a few weeks. We don't say that it's one of the most impactful hurricanes of this, weather season, hurricane season, because it wasn't, and we know that. So, in conclusion, watch pop science videos if you want to, but keep in mind that they necessarily simplify things to make them digestible for general audiences. In general, I do think this is a good video, and I do think that this is a good YouTube channel. But it's very clear that they do not have meteorologists on their staff when they wrote this video, and other videos like it. They have other videos related to the weather as well. And so I just want you to keep in mind that if you do watch pop science videos, while they are great for getting people interested in science, they shouldn't be used as a place to actually get conclusive, scientific information. That's all I have for you guys. Do you have any questions? Andy, sure.
So you use the comparison of Hurricane Patricia and Hurricane Sam as an example that surface level pressure can't be like a set indicator as well. But you also said that there is a massive difference in the places that Sam and Patricia impact. So if we have that wrench in taking that data, how can we use anything to measure those two storms?
That's exactly the thing that we're trying to get at, is that there is no single measure that can dictate how severe or how impactful a hurricane will be. That just doesn't exist. That's why, in addition to talking about its category rating, we talk about okay, well, the models say that it's going to make landfall here. What local terrain features are going to impact that? Where are people located within there? How are we going to evacuate them? What do the storm surge models say? Those things are all factored in with our assessment of hurricane severity. And that those are all factored into the decisions that emergency managers make when doing that. And so that's kind of the point, is that, yeah, no single measure is going to be enough to say definitively that a hurricane is going to be severe or not. It depends on so many other things. And that's kind of what I'm trying to get at. And something that the video alluded to as well, but I don't think they did it in a perfect way. I think Dr. Finch had a comment on what you said as well. So she says hurricane wind scale is a strength scale, not a damage scale. The entire premise of the video is wrong. Good choice for this presentation. Thank you, Dr. Finch. Yeah, that's a very good way to sum it up. It is a strength scale, not a damage scale. It is not meant for that purpose. Yeah, any other questions? Cool. That's all I have for you guys. Yeah, I would say in general, it is very important that we do talk about, how we communicate weather information to the public. It is very impactful. There will be discussions about this forever because weather is hard, and we have to communicate that in a way that people will understand. Like I said, there's a big difference between whether people have the information available to them to make decisions and whether or not they actually make the proper decisions. But again, that's for another presentation. Exactly. But yeah, I think that's all I have for you guys. I'm fine making this a little bit of a shorter meeting. I know maybe you have places that you want to be soon. So if you guys don't have any other questions or comments, I'll let you guys go. Cool.
So I think just one last question now. So if it's like low pressure inside, if like the lower it is, it's more likely to get the high pressure in, and it's like bring in high pressure from the outside. So how would that make it bigger? I like stronger.
That's a good question. Basically, I guess the lower the pressure is, it's an indicator of how strong the system is. So obviously, lower pressure will bring in more air. It's going to give it. The answer is I'm not exactly sure what the betting is. Sorry,
Let's think of it this way.
But
how do you perform under high pressure?
okay.